Hi, welcome back to the channel. In this lesson, we'll continue with how to find the resultant of three or more vectors acting at a point. We'll use this example to further see how to deal with resultants of vectors. Now, like we can see in this diagram, we have 5 forces acting at different directions. Like we said in our first lesson, the first thing to do here is to resolve each of these forces into their individual components. Each of them can be resolved into the x component and the y component. In case you missed our last lesson on how to find the resultant of 3 or more forces acting at a point at different directions, please do check our description below where we have placed a link for your convenience. Now, let's start with the first force. Let the 300 Newton be the first force, so that my Fy1 here will be equals to, now to solve for F11, now let's observe the force first. Now this is 300 Newtons and this is angle of 30 degrees. If you look at this angle of 30 degrees is inclined to the y-axis, so that my Fy now will come from cos theta, while my f of x will come from sine theta. And know that the f of x is acting in the negative direction, while the f of y is acting in the positive direction. So that my Fy1 will come from 300 cos 30, while my Fx1 will come from 300 minus 300 sine 30. Let's call the second force, let it be the 200 Newtons, so that my Fy2 will come from here, is acting at 45 degrees. Now with this, the y component of this is here. This is my Fy, that will come from sine theta, that will come from 200 sine 45, and my Fx2 will come from 200 cos 45 degrees. Now the third angle, the third force is the 100 Newton, so that the Fy1 here will come from negative. If you look at it, the Fy here is in the negative direction. That will come from negative 100 sine 60 degrees, while the Fx3, okay, this 3, let's call this the third first. Fx3 will come from positive 100 cos 60 degrees. Now the fourth force here is the 50 Newton. The 50 Newton is acting in the negative direction and is directly on the y-axis. So the Fy for Fy4 here, let's call that negative 50 Newtons. And the Fx4 here, because everything here is acting on the y-axis, my f of x will be 0 Newton. Now for the fifth Fy5, we're talking of the 400 Newton and is acting on the x-axis but in the negative direction. So the Fy for this is 0 and the Fx of this will be the same thing as negative 400 Newtons. Now let's do a recap for it. You see that the first one is the 300 Newton. The x component is in negative, we picked it as negative, while the y component is in the positive axis. For the 200 Newton, there is in the first quadrant, everything here is positive. For the 100 Newton, here, the y component is negative, while the x component will be what? Positive. Now, both my 400 Newton and the 50 Newtons are acting on both y axis and x axis. So let's sum up our components, so that the summation of y will be given as f of y will be given as 300 cos 30 plus 200 sine 45 minus 100 sine 60, now minus 50 Newton plus 0. 0 is 0. So let's sum it together. Fy now will come from 300 cos 30. The cos of 30 is the same thing as 0.866 times 300. That's equals to 259. That's 259.81 approximately, plus 200 times sine 45. Sine 45 Sine 45 is given as 0.7071 times 200. That's equals to 141.42 minus this sine 60, this 60, sine 60. Sine of 60 is given as 0.866 times 100. That's 86.6 minus 50. Now, so that summation of f of y will come from 259.81 plus 141.42 minus 86.6 minus 50. That's equals to 264.63. Now let's find the summation of f of x. My f of x will come from minus 300 sine 30. Sine 30 is given as 0.5 times 300, that's 150. Now that 150 is negative 150 plus 200 times cos 45. That's the cos of 45 times 200. That's 140 plus 141.42. Now plus 100 cos 60. Cos of 60 times 100. That's 50 minus 400. Minus 400. So that summation f of x now will be the same thing as, I have my negative 150. That's minus 358.58 in newtons. That means this summation, the f of x, if you observe, is acting in the negative direction. So if I'm to draw this, the first thing I want to do, put your Cartesian coordinate. This is my y coordinate and this is my x. Since I'm having summation f of x in the negative direction, that means I have it this way, and it's given as 358.58 Newton. Now what is my summation f of y? F of y is given as plus 264.63. That means I should have it in this direction, 264.43. 43 or 0.63, please. That's 264.63. 264.63. Now that means it falls in this axis. Now let's take, if it falls in this axis, I can simply resolve. Here is my y component, that's the 264.63. Then I can take this using Pythagoras theorem. This is my r. My r definitely will come from the square root of 264.4.63 all squared plus 358.58 all squared. So that my r now will come from the square root of 264.63, that's equals to 70029.04 plus 358.58 all squared. That's equals to 128,579.62. Now that's plus 17,029. Now will come from the square root of 198,608.66. Now so that r, the square root of this, r now will be equals to 445.66 newtons from my calculator. Now if r here is 445, if what I have here is 445.6 newton, I can now find the angle at which theta, at which this force is exerted. Now we can use tan theta now to be equals to opposite over hypotenuse 264.6 over 358. That's equals to 264.6 divided by 358.58. That's approximately 0.7379. Now we can now look for the arctan of this. That's from my calculator. Theta is equals to tan inverse of 0.7379, which is the same thing as 36.42 in degrees.